Okay, in this lesson we're going to determine what is the empirical formula of aspirin. And we know aspirin has the elements carbon, hydrogen, and oxygen. And we want to know the lowest whole number ratio in the formula, that is CXHYOZ, where X, Y, and Z are integers, and they're the lowest whole number ratio. Now the information we're given is that aspirin is 60% carbon and 35.5% oxygen. So the first thing we need to do is calculate the amount of hydrogen in aspirin. And what we know is that the sum of the percentages is the whole, or 100%. So 100 minus 60 minus 35.5 is 4.5%. And if I add these together, I get 100%. Now, since we're given percentages, the percent composition is independent of the quantity. We can choose any mass we want, so we're going to choose 100 grams. That makes life easy. If I have 100 grams of aspirin, I have 60 grams of carbon. I have 35.5 grams of oxygen, and I have 4.5 grams of hydrogen. Now, these are masses, these are atoms, so I need to convert my mass fractions to the number of atoms. So if I have 100 grams, how many moles of carbon, how many moles of oxygen, how many moles of hydrogen? So I divide by the molar mass, or 12.01 grams per mole, 15.99 grams per mole, and 1.007 grams per mole. And I now come up with the number of moles of each, which would be 5 here, 2.22 here, and 4.47 here. So I now actually have a formula, okay? My formula is C5 H 4.47 O 2.22. But these are not the lowest whole number ratio, okay? So this is not an acceptable formula. These must be integers. So the next thing I do is I divide by the smallest number, okay? Forcing one of these to be 0, and one of these to be 1, and the others to be a number greater than 1. So if I divide this by 2.22, divide this by 2.22, and divide this by 2.22, one of these must be 1, the smallest one, and the other must be greater than 1. So this becomes 2.25, and this becomes 2. So now I have a formula C 2.25 H, H2O. Okay? This is still not the correct formula because this is a fraction. Now, how can I convert these to integers? Well, one way is that every one of these numbers will be an integer and a decimal. Decimals are fractions, so I could say 1 over x is the decimal. So what is x? X is 1 over the decimal. So let's look at some of the common ones that we could have, okay? 0.2 is 1 over 0.2, which is 1/5. 0.4 is 2/5. 0.6 is 3/5. 0.8 is 4/5, okay? I could have 0.33, which the reciprocal of that is 1/3. 0.67, which is 2/3. I could have 0.25, which is 1/4. I could have 0.5, which is 1/2. I could have 0.75, which is 3/4. Notice 0.5 is the same as 2/4, and 2/4 is 1/2. I could also have 0.167, which is 1/6. Okay? So 0.25 is the same as 1/4. So I can now rewrite those as carbon as 8/4 plus 1/4 is 9/4. Hydrogen has 2, so that would be the same as 8/4, and oxygen is 1, which is the same as 4/4. So this ratio here is the same as 9/4, 4/4, 8/4. Now I multiply by the common denominator, and I have my formula, C9, that is I multiply each of these by 4, and I get 9, 4, 8. So my empirical formula is C9H8O4.